So that is the challenge of presenting on a stage without a screen. Let's see if that works. How many of you are developers or have been developers or whatsoever? Oh, right. Cool. Normally I start with the first slide that says DevSecOps. Who of you likes that word? Only 3. That is interesting because when I saw that word the first time, and it was like 5 years ago or something, I was like, come on, yet another buzzword? What's next? DevSec, Cloud, Biz, ML Ops? If you put DevSecOps next to AI and blockchain, at that point I felt like that's a full buzzword bingo. However, if you look at DevSecOps in general, if you look at DevOps, you will see that with DevOps, we tried to tear down the wall between developers and operation and make sure that it wasn't siloed, but there were basically it was connected towards each other and it was available in the same team. Or at least that was the intention. That we made all sorts of tooling and we thought that DevOps was about tooling, and now we have DevOps engineers. I had the luck that I had to work with Patrick Dubois, the founder of DevOps Days, who made up the name DevOps, which was just a coincidence because DevOps sounded better than OpsDev. Really, that's the reason. However, if you look at what we are trying to do with DevSecOps, it's trying to tear down. You've got the same issue?
Yeah. Oh, here it is. Let's try it.
You're not going to say that it's the projector that's not on. I'm going to push it in. What we try to do with DevSecOps is making sure that security is also in that game, in that same game, because security is not there in many cases with DevOps. If you look at a general team in whatever big bank, government organization, or insurance company, you will see that there's one security team try to help a ton of engineering teams. And the engineering teams are everly growing and they are independent and they are there trying to do their work. But there's still one security team. And of course, we've got something like security champions in that kind of case. But it's not yet there. It's still in many cases, it's siloed. And that is what we're trying to do, or we're trying to solve with the whole DevSecOps kind of thing. Now I actually need my slides. And hopefully, it sees the screen. Let me try your adapter. So I'm not sure what the problem is. It will be really problematic if I cannot have someone hack me, hopefully. Hopefully that is the case, and at least know what the problem is, right?
It's an HDMI, does it go to a desktop?
Yeah, it does. That's the
Did somebody pull the plug? Yes. Now we've got the second trick, spitting up all your demos again while you did that already. But we're gonna try it again because I was prepared for this and I wrote a script that hopefully spins up all the demos. Yes, more screens, cool. Yeah, we'll see. Cool. At least it spins up my demo. So now I can do the second part. I probably need to rearrange a few things on my screen during this session, but bear with me, please. You see what I had to deal with. So hopefully it spins up. Yes, here we have it. Let me get this one to this screen, and the rest we will find out when we come to that. So we talked about DevSecOps already. Oh, this is me, by the way. I'm Brian. I work for Sneak. I am a Java developer by heart. I develop in Java. Everybody makes mistakes, and you can judge yourself if this is a mistake or not. I do a lot in the community, co-leading the DevSecOps community, but also a lot in the Java community. It's not important because we need to talk about problem areas. Now let me enlarge this one. Because what is the problem? What are we actually trying to solve with this DevSecOps kind of thing? Well, let's look from it from a developer perspective, because that's what I'm going to talk about. I'm going to tell you a story about what I did. About 15 years ago, I worked for the Dutch government. I'm based in a town an hour south of Amsterdam, and I worked for the government, and we built an application that had something to do with identity data, like identity data of all Dutch citizens. We deployed 3 times a year, which is fantastic, because then my security team and my pen testers had all the time in the world to test. However, fast forwarding to, say, 4 years ago, when I was working for one of the major web vendors platforms in the Netherlands, which is basically the competitor to Amazon, my team was responsible for the servers that deployed 4 times a day. Good luck with pen testing. We were self-sufficient, we were autonomous, and we deployed 4 times a day. And that is seriously the case nowadays. But we see that in a general security, or in a general development team, there is a lack of security knowledge. Not many developers do get that in development school, in uni, or at college, whatever. What is security? They might know about SQL injection, and that's just as far as we go, pretty much. We think that security is nothing more than authorization and authentication, which is not the case. So the lack of security is not there. No, it's still that siloed expertise on the end. Which means that I'm cowboying around, making solutions, which are great, go into production, and after 3 weeks, while I'm already 14 iterations ahead, my security team comes up to me like, Brian, you cannot do that. And I can handle that. But most of the time, they come with me like, we did a test and we've got these kind of defects. That is not, well, I won't get very happy on that. So that means we get friction within these teams. And friction doesn't lead to good software, trust me. Friction leads to more friction, leads to like, it's always them. And they are like, oh, now it's always them, right? You get that feeling? It's like they're stopping me. And then the security team said, no, they're just cowboying around. But in the end, we need to meet these expectations of the C-level board and actually deploy into production because we need to be ahead of the competition. Anyway, in the end, we need to play along, actually, because we do not want customer data to get compromised as one of the things. Well, obviously, security is more than that, but that is the most recent thing, specifically when I worked in the government with identity data, trust me. Anyway, but how bad is that situation? Who of you heard of Equifax? Hans, who of you heard of Equifax before this hack? That is great marketing. Like at least 50% of the people know about Equifax now. It's a crediting company, obviously, in the US, but I'm not going into the company. That's not important. The thing was, they built their application at that point based on Apache Struts 2, a Java framework. However, there was a problem in that specific version of Apache Struts. But hey, at the point of when they went into production, it probably was fine. And look at the general Jira board or Kanban board of a development team. It's like, we're done, get to the next task, and it's always feature-based. As a product manager, I want if I click on this, it does that. Security is implicit, just like scalability and maintainability. However, now we're in the cloud, scalability and maintainability needs to be a thing, right? Security is still a little bit invisible. What means is that if you are going from task to task to task to task, and not already looking at what's already in production, which would happen here, you might get breached. Because the fix was already there, 2017 we're talking about, was already there in March. However, the hack was in May of that year. That means if they updated their version, minor version of Apache Struts 2, it was not a problem. However, 140 million US customers were compromised. It took over 76 days before they found out somebody was in, and they guessed it is about, the damage is about 2.0 billion US dollars. Okay, let me get into that hack actually. Because now I need to rearrange my screen, as you can imagine. Get this one here, and get this one here. All right, I have an application over here, and that application is not what Equifax was using, but this is actually the application with the same Apache Struts library in it. The thing is, I do not have to do anything special because Apache Struts is in here, and I just can use it from the terminal as a real hacker. So normally I would do my hoodie on, because that's what hackers look like in the movies. And, well, what I can do a curl request with a specific header. And this is the header. Who recognizes this header? Come on, we're smart people here. It's a content type, right? Content type, key, content type, value. Okay, what kind of content type is this? It's an invalid content type. And then you're like, duh. No, actually, because this problem in Apache Struts 2 was if you're providing an invalid content type, you go into an exceptional flow. In an exceptional flow, for whatever reason, we were able to utilize OGNL, which is the object graph navigational language, the expression language within Apache Struts. Java is an object-oriented framework, object-oriented language. And with that expression language, I was able, or you are able, to interfere with the objects that are in memory, or even load objects in memory. Oops. So what I'm doing here is basically saying, and now I have to look, I am not just calling a method, no, I'm actually building a new process builder. I'm just spinning up a new process. I'm saying, hey, do something with the bash and feed that bash any arbitrary command. Yep. And if I do that, and I reroute my, my output stream to my input stream, or the other way around, sorry, I can actually show it on screen. Basically, this gives me the ability to do a arbitrary code execution. Let me show you. Oh, by the way, this one is running on Heroku. So hopefully, and it's nothing to do with Heroku, but hopefully it works because Wi-Fi is always an issue. As you can see, it is Heroku, right? All right, let's go. What I'm going to do, I'm going to do this, and I will explain in a second what I'm doing. I'm using that header, as I showed you. Hopefully you can see it. Let me enlarge it. And I'm switching out the word command, and I enter the word env, A-N-V, which basically shows me the environment variables, nothing more. Curl request, a get to localhost. Well, it's not on localhost. No, it's on Heroku. So let's do that. And let's see if it works. Oh, what do you have? What we have here? These are the environment variables of my Heroku system. This is an old system. Think about what's working on your bank, right? Your bank is still working with outdated systems that nobody dares to touch for years, but because nobody's owning that, it's still there. So if we're not checking that, these kind of things might happen. This could have been prevented if we updated to the later version of Apache Struts, because actually the maintainers of open source libraries, most of the time, are very aware of when something happens, they need to fix it. It's up to the individual companies to actually apply these fixes. And in many cases, it's features over fixes, which is something that we need to address. Well, obviously this is not really important. I can see what's a Java home and all sorts of things, but if I can call the environment variables, I might be able to maybe insert a file with some content, come back tomorrow and actually execute that content. Good luck with your postmortem finding out what the heck happened. Or even worse, I might be able to insert a string that does a reversed shell execution, and then actually, hopefully, I can enter your system, depending obviously on the privileges of the user. Strict question. If I put this into a Docker container, what is the default user? Root. Hold that thought. All right. So that is what happened with Apache Struts. Now I have to look, that was it. So if this is your application that goes into production, a lot of it is not your code. Again, can I have the hands of developers or previous developers? I did develop something. I used to do PHP websites, that kind of things. It's also all good. Hands, still. Who of you does code reviews? Almost everybody. Luckily, I would say the rest does pair programming. It's fine. Anyway, we do code reviews, and we demand code reviews that at least four sets of eyes see something before it goes into production. These kind of rules I've worked with. That's fine, but your code is just this. This is the code, and we're very proud of that code. We do code reviews or pair programming or look at it, and it needs to be smart and efficient and we need to scale it. How about the rest? Because these are the frameworks that you inherit, and frameworks inherit libraries that inherit libraries that inherit libraries. Depending on the ecosystem that you're using, it might be available, it might not be available, or it might possibly be available. For instance, the Java ecosystem, everything that is on the class path can be loaded into memory. Yay for Java. So, a little quiz. I have a serverless application we wrote in Node. It had 19 lines of code. It had 2 dependencies. 2 dependencies because it's Node. How many dependencies do you think are actually in my system? Many. What's many? Give me a number. 1,000. It's not that bad. It was just 19. But still, instead of 19 lines of code, which most developers think we need to maintain, how many lines of code do we actually maintain at that point? How many lines of code is my team actually responsible for? Give me a number. Scream. 2,000? Almost. You get me? All these, it doesn't matter. It might be that these things are used, some of these lines are not available. Doesn't matter that much. We don't know, so we need to treat it as equal. Okay, this is Node, and it might be that some things are not available there. Let's go to a Java application. A Spring Serverless application. It was 222 lines of horrible code because I wrote it and it was a demo. A lot of duplication. But say it's an actual application. It had 5 direct dependencies. It's Maven in this case, and it reverted back to 54 dependencies, which is not a lot for an enterprise level application. How many lines of code does my team actually maintain? Give me a number. Not that bad for 60,000. And again, some of these lines might not be available, but everything in that is on the class path can potentially be loaded into memory for Java. So I can use it in a chain of attack. Not maybe a direct hit, but maybe if I can do this, lift something into memory, and then attack it, which is most of the case what happened. It's not as simple as I just showed you with the Equifax hack, but it shows that that thing was that important. All right, the use of open source has exploded over the last decade or so, which is a good thing, because why write another CRUD repository or something like that? Because I need to focus as a developer on giving value to my company. However, people that are malicious also looking at these open source libraries. And if it's known publicly that there is an exploit for something, or there might be something, it might be an exploit, you need to handle as a developer. But again, it's not on my Jira board. If we look at major ecosystems, and this is already from a report that we wrote in 2020, let's say Maven Central for Java and NPM for JavaScript, we see that most of the vulnerabilities are not so much in the direct dependencies that we declare, but somewhere 2 or 3 levels deep. And then it's always the discussion that I have with developers, but is it actually reachable or not? The other question that I ask, should you care? Do you want to care? Do you read actually all the code that you implement or inherit from an open source library? Probably not, because we need to 5 minutes? I thought I had 45 minutes. I had until 3:15, if I'm not mistaken.
Sorry, my mistake.
No worries. All right. Now I lost my story. Anyway, we need to look at the indirect dependencies as well, which obviously for most of you is like duh, but for most developers it's not the case. They're like, I just have 2 dependencies, right? It works. It works on my machine, ship it. Who should be responsible for security? Developers say, I am just a developer. We have a security team to do that, right? But if we ask around, people say it's a shared thing between developers, security, and operations, depending on where you look at. But if we look at application software, not so much the infrastructure, as I mean with containerization and for instance, the Kubernetes part of it. But if I look at the application, developers need to take their fair share. And how are we able to do that? We need to empower them. So let's do some more hacking, because that's what I promised you within this application, in the description. Okay. So I have an application here. I hope that it works. This does not work, because why not? Now it works. So this is a node application. It's a very silly to-do list. Right? Nothing really fancy. But it has an about page. And as you can see, this is the best about page ever, and the best to-do app ever, because if I go to my UX experts, like it's scalable, works on mobile. It's responsive, super responsive. People can look at it like it's black letters on a white background. Everybody can read it, like nothing fancy. Anyway, this is a node application, and this static page is served to us by the ST library. However, the ST library that I am using is outdated, and it has a path traversal problem. So let's take a look at that. So let's just curl for the application. Let's curl the about page, and I will get the about page. So I got a report that it might have a path traversal problem. So what would you do if you're on the other side of the game? What's the path traversal? What should I do if I want to get to the root or something? ... obviously. So let's do ... a couple of times, because we know if we do ... in the root, we end up in the root anyway. That doesn't work, because the ST library was actually designed with security in mind. Or so much that they particularly blocked ... And there's the thing. They block ... So let's be a little bit smarter. What can we do instead of ... Almost. %to-e. That would be a nice interview question for your next member on your team. What is the HTML encoding for a dot? And if the person says %to-e, like, you are my security champion. But %to-e is the HTML encoding for a dot. So I can do this a gazillion times, it doesn't matter, because now you see that I'm in the root of my system. Oops. And then you're like, if I show this to developers, they're like, yeah, so what? They can read. Oh, yeah, sure, but I can go to something like this and get information out of your system, because on your local machine, you're running as root. Oh, you do this in Docker, in a Docker container. Did you set a specific user? No? Again, you're root. This is JavaScript. This is Node. So what I can do as well, instead of going to something like the passwd file, I might be able to do something less intrusive and just go... should have a faster way of doing this. I could either retype it or... But let's look at it. It's satisfying. Just go back one level, and I see it's a interpreted language because I can look at the package.json, which gives me the, because it might not be an open source project, and I can now see like it has a lot of libraries. The MS library, which is vulnerable. The ST library is obviously vulnerable. What do we have more? We got Lodash, which is super old, jQuery. So this is new information for my next step in line. This is not a critical vulnerability, but even smaller vulnerabilities or medium severity vulnerabilities can be a part of an attack chain. So even if people dismiss it like the CVSS score is like low, who cares? No. Look at the impact instead of the CVSS score. And obviously, because this is JavaScript, I can do something like go actually into the app code. And oops, somebody forgot to erase a token. Yes, this was tricked, obviously. But still, you got me, right? So these things, even though they do not seem severe and developers might dismiss it, even though you have set guardrails as in everything that is not severe or does not have a score above a certain area, you can dismiss it if you think it's not applicable to your system. Well, it might be in a chain of attacks that I showed you here. I can show you a dozen more. However, I am limited in my time. What I can see is that if we look from our state of open source security from last year, we see that still a lot of vulnerabilities are ignored, and especially in the ecosystem I'm active in, Java. And because that reason is, again, we prioritize new features over fixing things. I know that I had, multiple times, I had a product manager breathing down my neck when this new feature came out because we needed to be ahead of the curve. However, by creating that, we probably created a ton of technical debt, and we know what comes from that. On this one, question, where were you December 10th, 2021? Exactly. I tried to go on vacation because it was in between COVID seasons and we were allowed from the Netherlands to go to our Caribbean islands, which was great. But on December 10th, this happened. I'm part of the big Java community and my mailbox blew up because something was happening in Minecraft. Turned out it was something with a log4shell library. Well, the thing was that it is still, and this is from last year, that still a lot of the log4shell libraries or log4j libraries that are vulnerable are still not patched. People are still downloading the libraries that are vulnerable. And the vulnerability to fix that or to exploit that vulnerability was super easy. A lot of people are like, yeah, maybe I've heard this one time, but I'll just explain it briefly. Say I have an application and I know something is logged with the log4j library. I can use a feature that they implemented in, I think it was 2013 already, to do JNDI lookups. And what I can do with a JNDI lookup, I can not only look at something, but actually retrieve that object. And that's what I'm using here. So if I know something is logged, like I'm trying to log in with a username and password. If I do a wrong password, you probably log the username somewhere, like user X tried to log in, attempt 1, failed, whatever, something like that, which is a pretty okay scenario. But I can use that, if that username is logged, I can use that to insert a string like this, which for whatever reason, I could utilize the LDAP protocol. Well, if I just spin up an LDAP server that points to a precompiled class that I serve to you via HTTP or something like that, you're actually taking that class that is precompiled into your system, even though it's foreign, and you execute it. Like, sure? Yeah, really, because if it looks like this, and this was the first hack, if I have a class that implements the object factory, and that means I need to override the get object instance, everything within the get object instance will get executed. So in this case, it opens my calculator. And I can actually show you if hopefully this one works. Let me see where I have, here. So let me arrange this. Nope, I want this there, and I want this one there. Cool. So I have an application here, and say I am logging in with Brian, and password is something like this. And it's wrong, obviously. So what I'm doing here, you see that in the bottom, the username Brian is executed, right? Or it's logged, and it's logged in this case with log4shell or log4j. I have my LDAP running and an HTTP server running locally. Because if I do this over the network, somebody will probably sue me, so let's not do that. So if I just do a JNDI LDAP call to my local host, to that port where my LDAP is running, and I have that code that I showed you on the screen deployed already, which is in this case compiled with Java 8, and I give it a wrong password, you will see that now, ta-da, my calculator spins up. Again, arbitrary code execution. I can use this to do a reverse shell attack. I can demo that in containers and that well, but you get the point. This took me, from that email to getting to this, took me about an hour and a half to first understand the thing, because there were the snippet, and then pretty much 15 minutes to get an exploit out. That hard. And it's still getting used, unfortunately. Even though with newer Java versions that have some guardrails in place, you can still use this to do to utilize deserialization issues if you have deserialization problems already in your class path. So it's still an engager to other problems and to utilize them. Simply updating would have been sufficient. All right. So what is the solution, you would say? Like, we have 10 minutes left, and let's talk about that a bit, because I can do more hacks than this, but unfortunately, something with the screen didn't work that well. I work for a company that does tooling, right? And one of the things we could do, obviously, I would say to anybody is, hey, let's go to your application and, for instance, let's scan it. And you could have known that within your application, and I don't need to create SBOMs or something like that. It just use the manifest file and your package manager to see whatever gets in, to see, hey, you've got a log4shell problem in this one, and you should update, because this is connected to my GitHub repository. I could have done this locally within my IDE, or, for instance, within my terminal, because here I did a CLI scan, and what you see here is like, hey, you've got log4j core within a Spring Boot 2.7. Let's go to 2.13.2 to fix a bunch of vulnerabilities. Even though if there are not, in some cases, packages that you cannot upgrade directly, because this one enters my system via a self-made package, it still gives you the versions of the core package that has the newer or the better solution in it. The thing is, just pointing out there are problems, and this is the problem, is not very useful for a developer. They're like, how to fix it? So, yes, I work for a tooling company, but the first thing I would say that tooling is not the solution. And then probably my boss would say, what? But it is the case, it's not tooling. The first thing is culture. There's three things: culture, process, and tooling. Culture is the thing that we need to make. First of all, we need to make developers aware that this is their problem as well. Because we do DevOps, DevSecOps, or whatever it is, but in the end, if it goes wrong, it comes to the development team. They need to fix it. If something goes wrong, they make decisions. They are in charge as an autonomous team to make these decisions. We push them to make these decisions, but we should also help them with that. So the other part of the culture is not just blaming them, but also making sure that if they, for instance, solve security issues, that we praise them. It's not a given thing that all things are vulnerability free, because it can be good now, but in time it might be vulnerable. So not just perceiving it as, hey, here's a list of defects, fix it because that's part of your job, instead of, okay, Team A or Team Alpha was there, they made a decision that they had to fix these kind of vulnerabilities because, and they did it within this range of time. Thank you for that. And praising a development team is already better than just blaming them. If we want to make this feasible and we actually want to shift left, it needs to start with culture. Education, making sure that development teams are capable of doing that, but also not just blaming, but empowering. Then looking at process. If the process doesn't fit, for instance, I still work at a bank, I have a huge monolithic application, and I know there's a vulnerability, but it takes 17 weeks to deploy, which sounds weird, but it still happens in some cases. I am not able to make these decisions right away and actually protect my system. Next to that, if we look into tooling, pick tooling that fits your process instead of the other way around. It's about accepting the fact that that development teams need to do that themselves, at least for a certain amount. If I say hey, you need to implement this in your CI system, which we have done a couple of times, the first thing I would do at 3 in the morning if they call me, how can I circumvent that check within the CI system because they call me at 3 in the morning and I want to sleep? And yes, I did that. I was that person. But if they empower me, they pick the tooling and they not say that I have to use it in a certain way to satisfy the tool, but actually the tool helps me in the way that I love to work, it is not a blocker, but an engager. So I am a person that loves to work from the terminal. I use the CLI tool. They don't force me to use the IDE integration. I can use the CLI tool, which makes sense. So I am able to do that on my local machine and not wait until my build is done, which is fine for a microservice, but not so much for a big monolithic application where a lot of government agencies still work with, unfortunately. So pick the tooling that fits the process. Well, with the tooling, obviously, we, Sneak, can help you, and I will go very fast. Code analysis, SCA, container analysis, infrastructure as code, blah, blah, a lot more. We all have the tooling available and for free. But it's not just that the tooling is available, it's that we need to be able to do this whenever we can. We say about shifting left, which means we need to make it available to developers to actually shift left, and that it works with their way of working, because they are efficient enough, they know how to work. We don't demand them how to work because they're self-sufficient and self-operating teams. So give them the tooling in such a way that they can provide it in whatever way they want. And I would say do it in every step of your CI/CD, on your local machine, which I did here, when it ever lives in your Git repository, because it might live there for days, maybe even months, and in the meantime, something can come up. Yes, you might have a CI pipeline. I am not a fan of blocking, and I know from a CISO perspective, they say, like it's not within policy, block it. Sure. But make sure that is known to your developers, and don't expect them at 3 in the morning to have a hotfix for your customer, and they got blocked by the system, they will overwrite the system. That's just the way it works. Because in the end, the CEO or the CFO is looking at the money instead of what the process is. So be aware of that. If you hard block, you might see it as a blocker and you might get that friction again. In some cases you need to, depending on what your situation is. But don't stop there. Whenever you're in production, make sure, let's look at the time, I've got 3 minutes. When you're in production, make sure that you still monitor. Because at that point in time, when I do, for instance, sneak monitor, what you see is that we can grab the dependency tree, and we can grab, for instance, the base image your Docker container is working on, and that is static at that point in time. If new vulnerabilities come up or new fixes come up, we can actively ping you instead of you have to look into that. Connect it to whatever, connect your Git repository to whatever can automatically update to newer dependencies, or at least make you aware that new versions are out, because you don't want to fall behind. Whenever there is a new version and you're like 15 versions behind, it's a lot of rework to do that. Anyway, in the end, it is not about shifting left. Shifting left is just part of the solution. Shifting left is one thing, but shifting left is not enough. We need to be sure that if we want to shift left and we want to help developers, that our culture and our process are in place, and we do not demand them just to work in one way. Because on the other hand, we want them to be autonomous, we want them to be efficient, and if we demand them to work in a certain way, we're just blocking them. So pick up the tooling, but after you fixed the process. That's all I have to say for today. My name is Brian, I work for Sneak, and thank you for your patience.